Loading out codes.
Hello, my name is Dries, and in this video, I'm going to be explaining the reasoning for the 5 LeetCode challenges that I completed. The challenges are array reduce transformation, filter elements from array, apply transform over each element, best time to buy and sell stock, and maximum subarray. The first challenge was array reduce transformation. The goal was to recreate the behavior of JavaScript's reduce function without using the built-in method. So my function receives an array, a callback function, and an initial value, and I created an accumulator and initialized it with the provided initial value. I then loop through the array during each iteration, and I call the callback with the current accumulator and the current array value. The callback's result becomes the new accumulator. After visiting every element, I return the accumulator. And for example, if the initial value is 0 and the callback adds each number, an input of 1, 2, and 3, and 4 to 10, this approach has a linear time complexity because it visits each item once. It uses constant extra space because it only needs the accumulator and the loop index.
Hey, CB, fam.
The second challenge was filter elements from array. The goal was to recreate the behavior of a filter without using the built-in method. So I started an empty array called filtered array. I looped through every input, passed both the value and its index to the callback function. And if the callback returned true, I pushed that value into the result. And if it returned false, I skipped it. This challenge helped me understand that filter does not transform values. It only decides which original values should remain. The third challenge was apply transform over each element. I created an empty transformed array. I looped through the input and called the provided function with each value and its index. Unlike filtering, each iteration adds one value to the result. So the value that gets added is the callback's return value and not necessarily the original value. For example, if a callback that adds 1, 2, 3, and 4, or transforms into 4, this solution also runs one linear time and uses linear space for the transformed array. The first 3 challenges were related because they all use callbacks, but the callbacks serve different purposes. Reduce combines the array into one result, filter selects certain values, and the map creates a transform value for every input. The fourth challenge was best time to buy and sell stock. A brute force solution could compare every single buying day with every single selling day, but that would require nested loops, which we don't use. Instead, I use one loop and track 2 pieces of information: the lowest price seen so far and the maximum profit found. So for each price, I update the lowest price. I then calculate the profit I would receive by selling at the current price after buying by that lowest price. And if the current profit is greater than the same maximum profit, I can update the maximum. So if the price is only decreased, the maximum remains. This means no profitable transaction will exist. This solution runs linear, your time and constant space. The final challenge was the maximum subarray. The goal was to find the contiguous section of the array with the largest sum. I used Cadane's algorithm. I created the current sum to represent the best subarray, ending at the current position, and I also created maximum sum to track the best result found anywhere. At each value, I can only make one decision. Is it better to start a new subarray with the current number or add the current number to the previous subarray? I calculate that using math.max between the current value and the previous current sum plus that value. I then compare the new current sum with the maximum sum, and both variables start with the first array available. This is important because it allows the algorithm to work correctly when every other number is negative. This solution runs in linear time with constant extra space, and all 5 submissions were accepted. The biggest lesson being learned was that many array problems can be solved with one pass while tracking the only information needed for the next step. The first 3 challenges improved my understanding of callbacks and array operations, while the final 2 improved my understanding of state tracking and one-pass algorithms. That concludes my explanation of my 5 LeetCode challenges.